Hello everyone, welcome to our channel. So we have come up with the new question asked in the GATE exam. So we will solve this question and we will also cover all the you know important concepts to solve these questions. So here the question they are asking about the time domain step response and they given I'm stating the question unit step response by T of a unity feedback system. Unity feedback system means our Hs equal to 1. As we know, in case of the closed loop control system, closed loop transfer function, we can write this is Gs and this is Hs. Feedback transfer function is, in case of practical scenario, feedback is a sensor transfer function actually. Alright, it may be a transfer function and maybe some scaling factor also we can use actually. So this is a reference input RS, this is our by output. So I'm converting all, I'm writing all in terms of Laplace domain. All right. So so they given question actually they given the step response also, and they finally they would ask what is the k value. Okay. So how to solve this kind of question? One thing here, in case of step response, they given the final value. Final value they given zero point 0.8. All right. Final value we can say, settled value we can say, steady state value we can say. So all terminology we can apply here. Okay. So all right. So here since they given the final value, we know the final value, so we can use the final value theorem. Okay. So as we know, final value is only applicable for the stable system. Means all poles should be lie in the left side of the S plane. Okay. So all right. So here I am stating the final value theorem. So here in time domain t approaches to infinity, time dies out, and this is like by t small by t equal to, in terms of the S domain, S tends to 0, S by S. Okay. Then we can straight away we can find out. So what is your final value here? 0.8. So 0.8 equal to limit S tends to 0, S by S. Alright. Then they need to find out the bias is. What is the bias here? It will be transfer function into RS. Here transfer function is a closed loop transfer function. GS by 1 plus GS into HS into RS. How is this coming value? GS by 1 plus GS into HS is simple. So here we need to find out transfer function. Either we can apply the Mason formula, yeah, straight away we can find out also, like, because this is a very simple transfer function. So like this error signal ES. So here ES equal to RS minus HS into by S. All right. And what is the by S here? ES into just cascaded, just multiply and then substitute this value here. So here, and one more thing, here you can see we need to find out the output by S. So you substitute ES value in this equation. For example, this equation 2, this equation 1. Okay. So by S value is coming ESRS minus HS and CS. So by S output. Okay. Then into GS. Alright. Then just collect the output in one side output term. So 1 plus HS equal to RS into GS. So by S by RS is equal to GS by 1 plus HS into GS. So here we can see in case of negative feedback system, in control system we only talk about the negative feedback system. Alright, then only system can be stable. So in case of negative feedback system, here we get the positive value. In case of negative feedback system, here we get the negative value. Alright, so in case of negative feedback system, overall output gain coming less than. Okay, alright. So anyway, we'll discuss all these things in upcoming questions. So here we find out the by, otherwise we find out the transfer function here, because this by is simple transfer only one loop is there. That's why, otherwise we can also apply the Mason's gain formula. Okay, Mason's formula. Okay, this is also a tool to reduce the block diagram into one transfer function. Okay, so all right. So here is just simple how to apply the Mason formula for this also, like this ERS and this is a GS and this is by S. Here making one loop, gain is minus GHS. So only one loop is there. What is a forward gain? GS. Okay. There is no non-touching. Okay. And what is delta value? 1 minus single loop gain and plus 2 non-touching loop gains multiplication, like that we can stretch out. Okay, so here is only minus GS into HS. So 1 plus GS into HS. So finally we get the GS by 1 plus GS into HS. Alright, okay, let me solve this question and apply, because hope you understood here. So what is the YS here? RS into product transfer function. Okay, CLTF. So which will be GS into 1 plus GS into HS. Since here unity feedback, so HS is equal to 1. Alright. So by S equal to RS is a unity step. So unity step means 1 by S. Otherwise, if some step, some amplitude there, we can amplitude also like 10, 5 by S, like that. Okay. So alright. So 1 by S into what is the GS value? They given K by S plus 1 whole square into S plus 2. Where we are getting GS value they given in question. Alright. Since S is 1, so there is no problem. And 1 plus K by S plus 1 whole square into S plus 2. Alright. So this is bias. Then once we find out the bias, how to just let me solve it. 1 by s ky s plus 1 whole square into s plus 2 plus 1, and this denominator part cancel out. Okay, so here we get the bias value is 1 by s into ky s plus 1 whole square s plus 2 plus 1 but plus k, and then right now we are in position to apply the final value theorem. So limit s tends to 0, s by s. So here you can say s is cancel out, so it's coming k by s plus 1 0 1 square 1 into s plus 2 s 0 2 2 plus k, and this value already know, this is final value, means settled value is a given question and tested response graph 0.8. So let me solve it. K equal to 1.6 plus 0.8k. All right. Then k, let me connect term 0.8 1.6. Okay. So k value 1.6 by 0.2 is equal to 8. So finally we got the k value asked in the question. So this is subjective 5, they will give him the value 8, but since they are asking 2 decimal, we put the 8.00, no problem. Okay, so this is final question, we whatever question they given, we solve this question using the final value theorem. The same question we can also apply, we can also solve using the study error concept. Okay, how to solve it? Like as we know, final value, settled value we know 0.8, but error value, study value is reference minus final value. Reference is 1 minus 0.8 is coming 0.2. In a percentage is coming 20%. Alright. So how to convert in percentage? Command minus output means final value by command into 100. Okay. For this system is not is given more or and 20% is too high. Practical scenario only is a 2%, 5% is enough. Okay. So for this we again that side is recommended to design the control system to improve the error and other specifications like peak overshoot, like that. Okay, so all right, this is additional information I'm stating here through this question. Okay, so since they given the unit input, they are giving the step input. So in case of error calculation, input also matters. Since they given here a step input 1 by s. Okay, so step input 1 by s. Okay, so here in case of step input, since this is a standard input, we can apply the a standard formula also. So as we know, in case of step input, what is a error formula is equal to ay 1 plus kp. Where is a is a 1 because here amplitude is 1. So 1 by 1 plus kp. Kp is a position error constant. How to find out position error constant? Limit s tends to 0 gs into hs, and they given, but they given gs into hs ky s plus 1 whole square into s plus 2. All right, So finally it's coming out, turns out k by 2. Okay, then if you apply in this error, so error is coming 1 plus 1 plus k by 2. So coming 2 by 2 plus k. Alright, and this we know this will be coming 0.2. So 2 to cancel out, coming 0.1. So 2 plus k is equal to 1 by 0.1 is coming 10. So finally again we 10 minus 2 is coming 8. Finally again k value coming 8, which is similar to earlier value but where we calculated now using the final value theorem. Alright, so here finally we solve this question 2 method, and like in case of here we use the kp value. Okay, and how we get this kp value, for this let me dive into more details. So for this we need to first of all derive the error transfer function es. Okay, so as we know already we discussed here, you can see here if you paid attention in this, you can see here es rs minus hs into cs. We need to find out es transfer function here. So let me explain. So es is equal to rs minus by s into gs. All right, how I how I'm writing here, you can see here simple na. Here we are subtracting here na minus. So here gs, this is by s. All right, so what is a by s here? We need to find out in terms of es. So it coming out, this is our es, this is our es. So by s is equal to es into gs. All right, so here let me substitute this value. For example, this is equation third, this is equation fourth. So substitute this by s in term in equation third, then we get the s value is rs minus by s is es into gs. Okay, this is not gs actually, this is here hs. Okay, this is hs. All right, so this is a hs. So let me collect this es term. So 1 plus okay. So we know we already find out this es. Okay, so here again we can apply the final value theorem. Why? Because we need to find out the et value. Okay, so here how to find out here error means generally we write here like steady state error. Okay, so here you can see t tends to infinity, ess equal to et, and since no need to convert again in time domain because it's going to difficult, and then because linear differential equation to solve is difficult, right? So we can straight away we can find out in the s domain. Okay, so here we get rs into es is rs by 1 plus gs into hs. Rs is our reference input, So for example, if you put the step input, then 1 by s is cancel out. So you'll get the final value you get like that. Limit s to 0, 1 by 1 plus gs into hs. We can also enter this limit because the other term is constant. We can also write like that. So this term, as already we discussed, is called the position error constant Kp. Alright. So Kp is equal to limit s tends to 0 into gs into hs. Alright. For the step input. And finally we know our error is a by 1 plus Kp. Okay. So and if you stretch out this more in case of uh, ramp input, t into ut. Okay. So here is like that I'm talking about. So this is rt, this is t. So here in case of rt, so what is the Laplace in terms of Laplace? 1 by s square. Okay. So how to solve it? Just apply this 1 by s square here. So 1 by s square. So 1 by s is cancel out. 1 still 1 by s there. So we can just enter in denominator. So it coming like that. Yes. Okay. So 1 by s plus s. S is 1 cancel out. So s gs. Alright. Limit s tends to 0. So s also 0 here. So finally it's coming out like that. Because s also 0 here. Once you put 0. Then limit s tends to 0. Yes. But here we cannot straight away put the 0 because if for example GSHS is coming 1 by s value, so s is cancel out. So it depends upon the HSH, GSHS whether consist of the pole at origin or not. Alright. So this term is called the KB value. Alright. Then final last one like our step signal, test signal like parabolic input. So parabolic input is t square by 2 ut. What is the Laplace? 1 by sq. So same thing we can apply here. So finally we get the es is equal to 1 by limit s tends to 0 s square gs into hs. So this whole term is called the k. Acceleration error constant. Kb is a velocity error constant, right? So let me summarize here. For step input, like this is my error, like step input, okay, and RT ramp input and parabolic input. What is error? Okay, so here in step input we get the 1 by kp and here 1 by kv, 1 by k. Okay, all right. So we will discuss this more about the our type 0, type 1, type 2. Okay, so like that we can discuss more. So for this question, we have solved this question in two method by using two method. One is a final value theorem, second one is a history error method. So like that we solve the question and we have also explored the find value theorem and steady state value theorem, steady state method. All right. So like that we can solve it. So that's all for this video. If still you have doubt, please do comments, and we will come up new questions asked in gate exam. So like this, slowly we can cover all concepts frequently asked in gate exam. So that's all. God bless you all.